True though.
Okay.
And it's going to be hard because there's people.
Stop showing off. We're recording your voice now. Millie,
Oh, yeah.
stop showing off about how good you are. Right, okay, so we're going to add with numbers that are in binary form. So what we're going to do, we're just going to refresh about binary form and number bases. So remember we looked at base 10. Base 10 number, you don't need to write this down. Okay, we'll just talk. Base 10 are numbers that are made up using 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So if you're counting something and you get to 9 things, you then go back to the number system and do a 1, then a 0. And then 1, 1, 1, 2, 1, 3. Okay? Get to 19, you do, and so on. So we can do that with any base. So base 7, for instance, would have
0, 1, 2, 3, 4, 5, 6.
Yeah, good. Okay, so there is no. The thing is, there is no number 7 in base 7 because 7 itself would be a
1, 6.
a 1, not 6, but 0. Good. So number 7 in base 7 is 1, 0. So in base.
Why don't you have to, oh yes.
Base 4, for instance, is 0, 1, 2. Okay, no problem. They spare. I put some more books outside in that box. If you go into that cupboard, I think I saw some left over from yesterday. Yeah, the middle one, yeah.
Okay, thanks.
So base 4 is 0, 1, 2, 3. There is no 4, so what would 4 be, Sophie?
0, 1. No, 1, 0.
1, 0. 5 would be
1, 1.
1, 1, and so on.
1,
8 would be here. 1, 1.
1, 1.
Okay. It's good that you're not saying 10 because it isn't 10. And then, of course,
Base 2.
base 2.
But why
that
don't
we
we
can,
do like base 6 and base...
we can. What?
Oh.
Should we do it?
No, I was just wondering like...
Base 6 is 0, 1, 2, 3, 4, 5,
0, 1,
1,
0,
0,
1, 1.
and so on. Yeah?
Base 2 would be a 0, 1.
0,
Then it
1,
would be 1, 0.
1, 0,
1, 1.
1, 1, and so on.
And then it'd be...
And
1,
we've worked
0,
out
0.
before, to make up a number base, for instance, if we have base 10, it goes units, tens, hundreds, thousands, 10,000s, and so on, yeah? Which means if I want to use these digits, like in base 10, for instance, a 9 in this column means I have 9 hundreds, okay? Which means I have 90 tens or 900 ones.
Yeah.
You realise that's what that means, yeah? So a 4 here means I have 4 thousands
Yeah.
or 40
hundreds
or
400 tens or 4,001.
good. And if I have a number, what would I say I have
For what?
for this one? So I have 300s and
1
no tens and
1 8.
no
8 ones.
8 ones. So that's why we would say 308. But if I had 2, 4, 7, you say that number as 200
47.
4 tens 47. 247. Okay? But when we dealt with base 2 or binary, we didn't have ones, tens, we had ones. What was next?
Oh, 1 2
1, 2,
4
4.
8
8.
16 32 64.
Okay, so if I have a number in binary as 1, 0, 1, 0, now we don't have the same language for it because we don't use it in language. We might use it for computing and things. So I would not be able to say 1010 because it's not base 10. it is 1, 8,
8
and 1, 2.
2.
So 1, 8 and 1, 2 is what I would describe it as. And 1, 8 and 1, 2 means I have
10.
10. So I might
So
write
that
it
would
like
be
10. Yeah. Now you notice how I've written 10 and not 1, 0 because 1, 0 is only 10 when we're working in base
10.
10. Good. So if I have 1, 1, 1, 0, 1, we would say it as 1,
1 16 and 1 8 and 1 4 and 1 1
and a 1. So that means I have 16 and an 8, which makes, yeah, 16 and 8 makes 24, plus another 4, 28, 29. So you're right. Right? So we would call that 29. Okay, so that is 29 in our language. All right?
So if we did a test, we would have to write it like that.
So if I said to you, well, it depends. If I said to you, write this number in base 10, you could write 10 and 2, 9.
Yeah.
But if I said write it in words, you'd write it like that.
Okay.
Yeah? Okay, so, and then we also looked at so we converted from that into base 10, but how did we go from base 10 to base 2, or binary? So if I asked you for, what was it, number 53, let's try and work out 53.
You would put 1 2 3 4.
Good, so we've got
1 2
1, 2,
8
4,
16
8,
16
32.
64, and then
Right.
we stop there.
So we stop, we don't need
Yeah,
the 64, do we? But
And
so we
now
can forget about. So we do have a 32.
yes, 1.
So we would do it by 53
minus
subtract
32 would be 21.
21.
So we don't have any.
So we have a 16
Wait, how do we have 16?
because there's 16 in 21.
And then we go under the 4, we put 1 because it's.
Well, hang on. So we've got. Let's take away the 16 from the 21. Leaves us
4.
5.
No, sorry.
So we would have no 8s left, but we would have a 4 left.
Yeah.
So minus 4 leaves us with 1. So 0, and we put a 1. Yeah, so that's how we did that.
So 53 is actually 110101.
Exactly. So I would say that number there equals 53. Yeah? Right? So you've got the same number, that's 53, this is 53, but in different number bases. Yeah? Is that happy last couple of lessons? Well, let's have a look then at, we are going to look at adding and subtracting, but just to start with, we're going to add. So it is possible to add and subtract binary numbers in a similar way to base 10. So 1 plus 1 is 3 in base 10, but we don't have 3s in base 2. But 1 plus 1 plus 1 becomes 1, 1 in binary. So you've got to figure out how do you do that. So in the same way 3 minus 1 is 2 in base 10, 1, 1, which is 3, minus 1 becomes 1, 0 in binary.
Which means 1 0 has to be 2.
Yeah, exactly. So you're getting it now, that the numbers that the marks we write on the page are different, but what we say can be the same. So yes, that is 2. This is 2.
Yeah.
This is a 3.
Yeah.
This is a 3.
No, that's why 1 1 is. Yes, yeah, I also thought the same, but then.
Yeah, so I would, if I'm not sure what it's called, I would say 1 1, but I can't say 11 in base 2 because it's not 11. It's actually 3, and we write 3 using 1 1, using binary code. Yeah? So, let's have a look at what it says.
So
Key
that's
addition.
why 1, 1, 1 equals 11. 1, 1, which is 3. Okay.
Yeah. So 1, 1, 1 is an 8. A 4, no, what was it? A 4, a 2, and a 1. So 1, 1, 1 is actually 7, not 111. Okay, let's have a look. Key addition results for binary numbers. Do you want to write those down? I know they're in your book, but let's write them down because they're key. So just write this bit for now. Okay, and this is what we're going to do tomorrow. So we'll do just addition results for now.
So we do addition results for binary.
1 plus 0 is 1. 1 plus 1 is 1, 0, and so on. Yeah. Okay. So let's have a look. Let's have a look at our examples. So you notice that we're still using a method that you recognise, which is. But what's it called when you write it in?
Column.
Column. So we're still using our column method. So that's the solution. Let's see whether we can get there. So 1, 1, 1 plus 1, 0, 0. Let's have a look whether we can do the same thing. So just add a new page. So we'll look at 1, 1, 1, add 1, 0, 0. Now, of course, you know how to use this, but in base 10, don't you? So let's see whether we can figure it out, but using base 2 instead. So 1 plus nothing is still 1. Okay. 1 plus nothing is still 1.
No, it's 1.
But 1 plus 1 means you've got to go up, so 1, 0. Yeah? So we write that as the 0, bring the 1 over, so we've got 1.
Okay, sure.
Yeah? Makes sense? Let's just check. Is that what we got? Yeah, 1, 0, 1, 1. And then we've got 101 plus 110. Let's do this before you write it down. 101 plus 110?
Yeah.
Okay.
So it would be
1 add 0 is
1.
1.
1, 1, 0. How is this still 1 and this is 0?
Oh, good question. It's because it's two different numbers, is it? Have we got that right?
Yeah.
Let's just check.
1, 0, 1.
But you've got two different numbers giving you the same answer. How is that possible? Is that not possible in normal, in base 10?
Oh.
Because what if in base 10, what if I did this? 4 add 7, or 2 add 9. What do you get?
11 for both.
Exactly.
If it's minus,
I've got the same answer with 2. So it's just that
I thought
these are different numbers, but then when they add together, they get the same answer.
because I thought because the 0 was below. It makes it
But
0.
that's subtraction. Yes.
Okay.
So this is addition, isn't it? So obviously the fact that they're the same answer doesn't really. Do you know what these numbers are? What are they in base 10? So what's 1, 1, 1?
7.
So is 7 plus.
How do you know it's 7? Because I did it in science. That's why.
How do you? Because it's
I didn't.
a 1, a 2, and a 4. So a 4, 5, 6, 7. Underneath, a 4.
4.
So it's plus 4. Well, that's what I wrote here.
11.
Yeah,
So that's 11.
makes 11. So this number should be an 11. So is it 8, an 8, a 2, and a 1 makes 11. So what's this
it's
one
the
then?
Same because it
So
has the
a
same.
4, a 2, and a 1. So this number would be 4 and 5 plus
2.
6. Well done. 5 plus 6 is 11. So it's good that both number systems give you the same result. We get the same answer, and it should be right. Should be the same result. Make sense?
Yeah.
Go on then. I'll let you write that down. So this is in primary. This is in base 10. And I will just highlight this top row so that you know that's not part of the sum. That's part of the labelling.
Oh, right.
Actually, might be where I do it in a different colour that's not as bright. I like using my tool for different colours. So 8, 4, 2 and 1 are not part of it, they're just labelling for the columns.